So number one, you say. So the thing about, so this is practice quiz. Dunk, dunk. Number one. Uh, you should identify that the Z's are all ready to cancel. Do you see that? So rather than copy the problem up here on the board, I'm just going to do the row operations since you have the problem on your paper. So we're going to have, the first thing we're going to do is row one plus row three. And we're going to make sure we write that down. And when we do that, remember, we're not doing a matrix here like we have been the last few days. So we're just going to show the world what happens if we add row one to row two, or row one to row three, excuse me. How many X's will we get? Good. So we have negative 3X's. How many Y's will we get? Perfect. And then the Z's, of course, will go bye-bye. And then what's our number on the right going to be? Negative 51. Correct. Now we need to create the same elimination again. Since we killed Z's, we have to kill Z's again. You can't go rogue. Not that you would in a problem like this, but we have to go after Z's again. So what's our row operation this time? That's the only right answer. You have to take row two plus row three. Well, that's a bonus if you get a double kill, like just like in Halo, you ever play Halo online with people and double kill. Like this is good. Sorry, I just said that on a recording. I feel like a dork. But if you do that in math, it's actually really good news because then we get a bonus and we're actually closer to the end. So let's see what happens. So if we add row two plus row three, our X's cancel. Huh, we didn't even mean to, but they did. How many Y's do we get? How many Y's do we get? Yeah. And then, of course, the Z's cancel. We knew that. And then what's the number on the right? Yeah. So I get a lot of questions about this because people assume that something has gone wrong. But actually, nothing could be further from the truth. Something went very, very right. And what's great is that we don't actually have to solve this system right here the way we're used to, because this is just a little gift from the math gods. That's just a little baby one variable equation that we can solve. How do we solve that yellow equation? I mean, you just solve it. How do you get y by itself? Just solve. You do. And if you divide both sides of this by negative 5, then you actually, this is great news, you get y equals positive 4. You see? So we can now construct our answer somewhere maybe down here. And we're going to put negative 4, or excuse me, positive 4 right in the center like that. So far, so good. Normally, like you'll see in example 2 or problem 2, this step right here in the red circle or oval will involve more work. But in this case, it just fell into our lap. And now all we have left to do is take the 4 and plug it somewhere into this equation. Like I need a place to find Z, or excuse me, X. And that equation is just custom built for us because if we take the 4 and put it right there in place of Y, we get ourselves another little baby equation with just one variable. So what will that top equation say if we change the Y into 4? Okay. Nah, because it's a negative 9 being multiplied by a positive 4. Mm-hmm. And once again, we have an equation that your pre-algebra teacher probably taught you how to solve, and that is just add 36 to both sides, giving you negative 15, and then divide by negative 3, giving you x equals 5. And we can now go down to our solution and plug 5 into the first spot. And with these 3x3 systems, it's that storming the castle idea. Like we have to go rescue Z. We have enough power now to do that because in the original system, there are three variables. And in order to find one, you need to know two. And hey, happy day, we know X and we know Y. So the question for you now is which equation of the originals on your paper do you like the best? First, second, or third? Yeah, okay, that's probably a solid choice. So the second equation is 5x minus 3y minus 5z equals 3. And I'm just showing a little bit more work here so that I don't have to go back and explain what I did because we're going to change those into numbers. So what are we going to put in the first blank? Right there. 5 there, 4 there, because those are the things we know. And anytime you change letters into numbers, your goal is to get it so there's only one letter left, because we can solve any equation in the world that only has one letter. That's the goal. And from here, the thing I have no say in or no control over is, will our math be good? Because kids do crazy things. Like when we're learning how to do math, we say weird things. So what's 5 times 5? And then what's going to come after 25? Yeah. And then what's the next thing we have to do? Yeah, and what is 25 minus 12 right there? Mhm. And then yet again, we find ourselves in a situation with just a little baby two-step equation. How do you solve that?
Take off 13.
Yeah, so what's left? Divide both sides by -5, and you get Z equals. And then you go up here, you plug a 2 in there, and then you put a box around that. You do a little happy dance, maybe pause and have a sip of a nice cold beverage. Pat yourself on the back. I did it. Where you're going to find a difference in problem 2 is that I didn't set it up for you with one variable. Oh, all right. Well, then you're good to go. Cool. Number oh. So I'm going to start. Hey, did you divide any rows or did you just copy it down? Okay. Hey, young folks, pro tip, life hack. When you get to the quiz, any chance you see to divide numbers right away, you should take. Now, I'm about to do this problem with Haley, so I'm not going to because she didn't, and I want mine to look the same as hers. But if I was just on my own about to embark on problem 3, I would take that top row and I would divide everything by 2. Does it make a huge difference? Nah, but the smaller numbers are always going to improve our odds. So, and the same is true on number 4. On number 4, I'm going to get a lot of questions on 4, I assume, because there's no Z, but that's not the point. The point is, look at those bottom 2 rows on number 4. You could divide both of them by 2. So just improve your chances when you copy it down into a numerical matrix, because that's going to be step 1 in this section is to copy only the numbers. Take advantage of the opportunity. Okay, but let's not, because I want to do what you did. Okay, so I'm going to copy it down just as is. So we have -4, -2, -2, and 10. And then the middle row is -2, 5, -4, and 5. And then we have -1, -6, 3, and 4. What's our goal?
-2, row 2.
Okay. So row 1, you put that right here, I sure hope, right? Make sure you write your row operations where the result will go. Okay, that's how I know. You write a row operation and then I look for the results right next to it. Okay, so row 1 plus -2 row 2's. And since row 1 is the worker, I'm going to copy him down. It's a little bit annoying, but boo-hoo, no big deal. Okay, so we're going to go through now, and our target really is to make this number a 0. That's all we care about, right? Okay, so I'm going to do your row operation. I'm going to do it in a little bit of a different order. I like to multiply before I add. So I'm going to take everything in this row times -2, which is 4, plus -4, which is 0. And then I'm going to take this 5, where I'm moving my pen, times -2, which is -10. And -10 plus -2 is -12. And then I'm going to take this, where I'm moving my pen, times -2, which is 8. 8 plus -2 is 6. And then again, I'm going to take where I'm moving my pen, times -2. That's -10. And -10 plus 10 is 0. It'll change. Numbers are going to change a lot. The only things that aren't going to change are the zeros that we're making on purpose. If we do this in the right order, the zeros that we make are untouchable. Okay, but anything else, like if you were to see a 35 right here where my pen is, next step isn't going to be a 35. It's going to be like a -19 or a 2. Everything changes. Shall I? Okay. Okay. And did you do the bottom row yet?
Yeah.
Okay. What's your row operation going to be? Row 3. And remember to write the row operation next to where the answers are going to land. So, do you want to carry on? Like with me or without me? Why don't you? What's that? Yeah, why don't you I'll pause this and then you work out the row and then I'll work out the row and we'll compare. Sound good? Okay. Did you get that? Jackpot. Now, I am not going to ask, I'm going to boss you here. Actually, I am going to ask, but then I'm going to boss you if you don't answer correctly. What should we do now? We should divide as much as we can, right? It's going to make our lives easier. So we're going to go through now and we're going to take every single row, and you don't need, this is when, like I said before, you don't need to explain to me what you're doing here, because when I see you just press two matrices side by side, I'll know that you're just dividing. Okay. So what are we going to divide everything in the top row by? Sure. So that's going to become -2, -1, -1, and 5. What are we going to divide everything in the middle row by? Yes, divide by as much as you can. And every row is its own entity, so we can treat each of them however we want. So if we divide by 6, we knock this down to a -2 and a 1 and a 0. And then what's the bottom row going to divide by? Yes. There are some who might say that that's a waste of time. Those people are really not, they're not right in the head. Did we get closer to the answer? No, but we sure made the rest of the journey more pleasant, right? So I'll arm wrestle or fist fight anyone who wants to argue that. It was time well spent. So now we have ourselves smaller numbers, and it's time to do the middle number. So now our worker is right there, and his job is to work upwards to create a 0 and downwards to create a 0. So I am now going to leave a space, and I'm going to copy the middle row. And I'm going to do my thing. You're going to help me with this. So for the yellow arrow, how are we going to upwardly infect and make a 0 up there? Sure, I like that. So you're saying we should take -2 times the first row plus just an unmodified second row. I like that. And we write it there because that's where the results is going to go. Well, don't do that. Okay. Remember, always write it where it's going to go, not where it's coming from, where it's going to go. So what's this one going to be? Yep, I'm ready. So like, let's fill in our top row. I would do one row at a time. Like I don't want to go write another row operation. We'll cross that bridge in about a minute when we get there. Same as before, I'm going to write it up here and you're welcome working on your own. And then when you're ready, you can look up and compare our rows. Okay. All right. How'd you do? Fantarvelous. So now we're going to use the red arrow and go downwards and try to make a 0 in this 11 spot. This time we're going to have to do a double row operation because I can't just slick turn 2s and 11s into each other. So what am I going to do? Yeah, that's always a trick that works. It's not always the most efficient, but it always works. Yep. It's like if you had a 4 and a 6, you wouldn't multiply them by each other. You would turn them both into 12s. But when you get 2 and 11, like, yeah. So perfect. So what's that row operation going to look like? 11 times row 2. Perfect. And our row operation should be listed high and low because we're not doing the middle, right? Perfect. So again, go ahead and work it out and we'll compare here in a moment. Yes, ma'am.
So I have a -1 on top and then a whole thing in the middle and a dot right.
Do you have a +2 for the purple number? Do you have a -1 next to it? That's fine. So Hugo was asking about this. If you ever see me have a row and your row is the same numbers, but all the signs are different, then your equation and mine are the same. What matters is like where we decide to put negatives. So like, whereas I might have done -2 of these top ones times this middle, someone else, you might have done 2 times the top one plus the opposite of the middle. And when you have to put a negative in, where you put it is up to you, as long as you get the job done, right? So whenever you see an entire row opposited of what I have, all's good. Yep. I will say again, it's why I haven't been making answer keys, because then people who actually study and look at things would stay up all night wondering how I got it. And it's like, we can have the same, they just may not look the same. Where someone would get really confused is if they fail to spot opportunities to divide. Those people are going to really struggle. Every time you can divide, you should. So no sweat. So 11 middles plus 2 bottoms. 11 middles plus 2 bottoms 11 middles is 11, and negative 14 is negative 3. 11 middles and 2 bottoms is negative 6. Great. Now, at this point, I don't think necessarily that it's worth it. I mean, I don't mean to contradict myself, but even, yeah, the bottom row could be divided out, but really, is it worth the time? Because these numbers in this column right here, I'm going to put a green box around it. That is almost as user-friendly as math gets, right? I mean, like, so do you want to take the 30 seconds and divide? I don't know that it's worth it. So I feel in this case, like we can just press on and finish the problem because we're done. We just need to finish. So we need to take this purple number and use it to infect upwards. It's going to make the 1 and 2 a 0. And then when we're done with that, it's going to make the 3 and 2 a 0. So because we're on row 3, well, we're on the third step, I'm going to take the bottom row and I'm going to copy it down.
I was like, no elimination.
Got it? All right, so what's our row operation going to be to make the middle one a 0?
Okay, so that's
Perfect. Row 3 plus triple the middle. So row 3 plus triple the middle is nothing, plus triple nothing is still nothing. Right? You remember that 0 about 10 minutes ago that was causing you stress? Do you see how it changed? So sometimes they'll hang around. Usually, though, they're going to just kind of change as the problem goes on. So that's all. I'll be right with you, Jordan. Okay, we're going to just wrap this up. Are you ready to do the top row, Haley? This would be a nice treat if this happened on a quiz where you get to the very end and you just literally have to add 2 rows together. Like, what a nice way to finish, huh? So our final row operation should be row 3, just straight up plus row 1. Yeah, that's solid finish there. Did you make it? So we can tell we've done a good job when we look at the divisibility. You can see that negative 16 is divisible by 4. So in this row, we get 4x is equal to negative 16. In the middle row, we get negative 6x is equal, or negative 6y. So sorry, negative 6y is equal to negative 6. And then in the bottom row, we get negative 3z equals negative 6. And if any of these come out to be fractions, then that's really bad news. Like really bad news. That's why we just want to be so hyper uber careful with every step we do, because going back is right. So we're going to wind up with x equaling negative 4, y equaling positive 1, and z equaling positive 2. And then the last thing to do is just write the answer, negative 4, 1, 2. Yes, I can.